What's up, folks? Welcome back to the channel. In this video, we're going to build a very simple automation, and I'm going to demo it right now so that you see what we're going to do. So I'm going to start it off, and I can send a message like research about prompt engineering, and I can give my agent a few tools, and then research about how to use LLMs for code generation. And also I can give this agent a few tools. So essentially I'm going to be distributing tasks for agents with a customized set of tools that I input during runtime. And then I can just send this off. And then what that does is it's going to trigger an automation that's gonna yield a response that not only the model is gonna be performing the tasks that I asked for in Telegram, but the model is writing down files and whatever other artifacts needed locally on my computer. And we're gonna learn how to set this up, and it's pretty fun. So let's get started. Okay, so I'm gonna minimize this for now. And what I'm gonna do is I'm gonna go over here and I'm gonna stop running this agent for now. And we're going to build it from scratch so that you see the entire process, how it's done, how it's organized. I kind of organized it here so that you can follow along. Let me just organize here because the code is quite extensive. So I'm going to use some cheat codes here on the bottom, folks. And let's see what happens. Okay. So one of the first things we're going to do is we're going to start with the AI code first, and then we're going to write the code to integrate with the Telegram bot. All right, and then I'm going to walk you through the API tokens that you have to set up and all that stuff. So it's pretty simple. So first things that we're going to do is we're going to import Pydantic for the structured output stuff that we're going to use, and I'm going to save this as agent. So I'm going to save this as distributed agent tasker something. There you go. And then we're going to use OpenAI. So I'm going to say from OpenAI, import OpenAI so that we can import GPT-4o mini, GPT-4o, etc. And then we're also going to need lists from typing so that we can do some type hinting. We're going to import OS. We're going to import sys to handle inputs from the command line, so for testing. And then for the agent stuff, folks, this time we're going to use LlamaIndex. So I'm going to go LlamaIndex.llms.openai, import OpenAI, import OpenAI as Llama OpenAI. Although I kind of don't like this import, but okay. Llama OpenAI like this. And then from LlamaIndex core.agent import React agent, which is going to be responsible for doing the search and all the other stuff. And then from LlamaIndex core.tools import function tools so that we can create different tools for different purposes during this automation. All right. And then finally, we're going to use requests for handling web scraping tasks when needed, and beautiful soup for the same purpose. All right, folks. And then after that, what we're going to do is we're going to use SerpAPI, which is from that Google search results Python package, which is going to handle the the part of the code that's going to be the searching, the web search stuff. So it's the web search tool that we're going to use. Okay. First thing that we're going to do is we're going to set up an OpenAI API client. So I'm going to say client is equal to OpenAI. Now, if you don't have an API key set in your environment, do that. All right. So set something like API key equal, and then you put your OpenAI API key. All right. Beautiful stuff. So if you don't have that, do that. I already have it as an environment variable, so I'm not going to be setting. And then we're going to set up the models we're going to use. So I like doing that in the beginning of the script. So I'm going to set model task handler to be GPT-4o mini. And this model is going to be responsible for taking a big string containing multiple tasks and then extracting exactly all the tasks inside. Okay, pretty simple task. And then we're going to also use model agent. And this is the model responsible for actually performing and executing each task. And for that, we're going to use a more powerful model. So we're going to use GPT-4o, right? And finally, we're going to use a folder base that's going to contain all the artifacts that are going to be generated during this execution. And that's going to be called agent artifacts, all right? So everything that it's created during this, during the execution of any agent is going to be saved under this folder called agent artifacts, all right? So now that we've done that, what we're going to do? What we're going to do is we're going to set up a few extra parameters and we're going to start writing the actual code. So the first thing that we're going to do is set up the parameters for the SerpAPI, which does the web search. So we're going to do SerpAPI params is equal to, and we're going to set the engine to Google. And besides that, we could set a bunch of stuff, but all we need to set is this and the API key, which if you don't have it, you should go set it up. And I'm going to leave a link to the description for all the websites that you might need to go to set up your API keys. Essentially, we're going to have to set up SerpAPI key, OpenAI API key if you don't already have that, and the Telegram bot token, which is pretty easy to do when you have the Telegram app installed in your machine. All right. So now that we've done that, folks, we can actually start writing some actual code. So the first thing is that we're going to use Pydantic to do structured output extraction from the string that the user sends to transform that into a bunch of tasks. So for that, we're going to create a class called task handler. And then that's going to inherit from base model. And what that's going to do is it's essentially going to have one attribute, which is going to be a list of strings, which is going to be a list of all the tasks contained in the message sent by the user. All right. And then we're going to give that description here. So it's a list of tasks, extracted from the user's message. Okay. And once we've done that, we can now write a function that makes a call to the ChatGPT API and leverages this class, task handler, as the response format, so that when we send a message to the model saying, look, these are the tasks, the model is going to return a list containing all the discretized tasks inside. So that's pretty easy. We're going to write a function called generate task list, and that's going to take in one input called task input, and it's going to return a list of tasks. All right, a list of tasks. Perfect. So now we do that, and what we're going to do is we're going to first we can document this. So generates a list of tasks from the user's message, and we're going to set response equal to client.beta.chat.completions.parse. So this is because we're going to be doing structured output extraction here, and we're going to set the model to the model task handler that we set before. And Cursor's already helped me out here. So the messages to the model are going to contain not only that, so this is missing one thing, and that's it, the system message. And the system message is going to be the message that describes the behavior that we expect from the model to extract these tasks, okay? And to not be writing all of it again, I'm just going to copy the system message that I have here, all right? So let me just put, so this should be here, so this is role, and then this is system. And then the content of the system message is going to be what? It's going to be something that I'm just going to copy from the reference code that I have here, folks, because it's way too much text for me to write again. But we're going to walk you through what that message is saying. So don't worry about that. And let's do that. Okay, perfect. So we're copying it. And here we go, folks. There we go. We go back. Boom. So let's walk you through what's going on over here, folks. Right. So we start with you take in text as a list of bullet points containing task descriptions with potentially 2 calling indicators specified with at tags, and you output a list of those tasks. And you output a list of those tasks. Where each bullet point is an individual element in the list. And for example, if the input is basic techniques, if the input is, then I could put like a So I'm improving as I show it to you folks. So that's some live updates just for you. So if the input is this, and this is what you should show. There we go. So if the input is something that looks like this, yeah. So if the input is basic techniques of prompt engineering, and then I give this, and then LLMs for research, what is going to be the output? The output is going to be essentially a list of those tasks. So as you can see here, I'm giving the model an example of that list what that list should look like to just guarantee that the model doesn't get it wrong. And the weird thing that we're doing here, folks, is that the task not only contains the description of what should be done, but I'm always, and this is just the choice I made right now because I want to play around with this idea. I want to create the agent when I send a request to the agent, instead of having the agent already created beforehand, because that allows me to customize which tools the agent can use right from my prompt to it. So I'm using this at tag, and then I'm saying, look, do web search, do write file, do read file, and we're going to have a set of other functionalities that we could integrate to this agent. All right. So we do that. That's awesome. That's great. Beautiful stuff. So now that we have a system message, now that we have the message that we're sending to the model, what we're going to do is we're going to get that response, parse it back, and we want the parsing it back to have the list of tasks. So that's why response format is set to task handler, right? And for some reason, this is giving me some grief. So let me see what's going on over here. So this is there, this is over there, this is over there. Okay, so I should have done this. There you go. So now that we've done that, folks, we're going to parse and return those tasks that are retrieved. Now, this is not a perfect solution because we could implement some error handling here to avoid having issues where maybe the model doesn't identify any tasks, so there's some problem with the extraction. But I feel like for this example, we're good. We're good with just that. Okay. So now that we've done this part, what we're going to do is we're going to go to the next part, which is to extract the tasks and the tools from each of these inputs. What does that mean? This is what it means. What we're going to have is we're going to have a function that extracts from a string that looks like this, what is the task and what is the tools that I'm giving to the model, which is the stuff that has this at tag associated with it. Now, I don't know if this is the best approach, but since I'm going to be writing some Python code to extract this, I feel like this could be pretty consistent, reliable, etc. Okay, so just for you to get a sense of what this function does, let's just write a little test here. So I'm going to write generate task list, and then I'm saying, let's create just like a couple of examples. Yeah, there we go. And now that we've created this example, let's run it and see what happens. Okay, so I'm going to run Python distributed something. And now I run it, and I got an error. Cannot import React agent from LlamaIndex core.agent. That's weird. So let's fix that error right now. Cannot import LlamaIndex core.agent. Let me see here. Let me copy it from my original. Index. Okay, so LLMs.OpenAI. Import OpenAI as LlamaOpenAI. That's correct. This one is giving me an error. LlamaIndex core agent. LlamaIndex.core.agent for React agent. There you go. React agent like this. I was just getting it wrong, the letters there. So now we can run it, folks. And there you go. So the task that we sent, now it's parsed into this list perfectly. We have basic techniques of prompt engineering, and then web search, and then LLMs for research, and then web search, right? So that would mean that we have a task that would be about researching about basic techniques of prompt engineering. And we give this tool so that the agent only has the tool that it needs to perform what we want the agent to perform. Now, obviously, for like many tools, it would be kind of like ridiculous to expect the user to describe, I want you to use these tools. But for me, I want to have the most control possible when sending the messages to the agent so that I can have some control over the execution of the task. Okay, so that's pretty cool. So now that we have that, folks, we can comment this out, and we can write the next function, which is going to be to extract the agent tasks and tools. All right. So let me just, let's go back here, agent tasks and tools. There you go. And tools. And what this is going to take is, this is going to take in the task input, and then it's going to return, essentially what this is going to return is just the, a tuple containing the tasks and the tools inside of each of those tasks, okay? And we're going to show an example to make that super clear. So, tuple, so we're going to have to import tuple as well. So let's, maybe I'm not going to add this. We don't need type hinting here. That's fine. There you go. And then we're just going to write a little doc string here that extracts the tasks and the tools from each task, for each task in the list. There you go. So what this thing does is it will loop over all the, it will take in a string containing the tasks, and then it's going to split that into parts, and then it's going to extract the part that is a task and the part that is a tool. So what does that mean? That means this. So words equal to task input dot split. Okay. And then what we're going to do is we're going to say, what are the tags? So we're going to say word for word in words if word dot starts with this, because this guarantees us that we're going to take in the tag. The tag is always going to be one full word. So we're going to, if we use split, we can identify this immediately. And then when we've done that, what we're going to say is, look, the task is everything, all the words that we had before, except the stuff that has the at tag. So it's essentially all the stuff from task input besides these tags. And we could have done this with index, but I like doing like this. So we're going to say word for word in words, if not word dot starts with tag. Okay, now that we've done that, this is pretty great. Now I'm going to say task. And now that we've done that, we're going to say return task.strip and then tags. All right, that's what we're doing. That's the whole thing. And the reason why am I doing task.strip here? It's a good question. I might have generated this line with AI, and I don't remember why I do task.strip here. But let's see what that looks like. All right, folks. So let's print an example. Extract agent. And then here, the agent's going to take in this task right here, right? This is going to be an example of a string extracted. Let me just go back one. There we go. And let's see what it looks like. So let me just delete this. There you go. Okay, perfect, folks. This is what we need. So as you can see, the extracted stuff is a string containing the task description and a list with all the tools that were extracted from the string there. Okay. And now that this is working great, we can move on to the next part. And the next part is going to be to write all the tools that we need to give to the agent. And we're going to give this agent web search capabilities, where it takes in a string and returns a string containing the results of the research. We're going to give a tool to write a file. We're going to give a tool to read a file. And I feel like for now, yeah, the only one that's going to be extra is going to be the scraping the website, which is in situations where you might have like a URL, for example, that you want the agent to go in, take in the information from there, and maybe write like a summary and save that to a file, etc., etc., etc. Okay. So, so there's another one that's going to be called scrape website, and then it's going to take in some URL, and the output is going to be a string containing the results of the scrape. Okay. So now that we have all of these, folks, we got to write them down, right? So I'm just gonna, just to be quick, now let's write them from scratch because they can be sometimes a little bit tricky. So it searches the web and returns the results. There you go. So we're gonna be using the SerpAPI like I was talking about. And for that, we just need to say Google search, and then we give the parameters that we've specified in the beginning of the script, right? And then we give the query, right? We set query to this, and then we set the number of searches that we want. So for that, we need to do this, and then we say Q to query, and then we set N to 5. We could have a different N with different number of search results. This describes how many results we get, but I feel like N to 5 is pretty good, okay? Now that we've done that, we're gonna get some results. So the results are going to be what? Search.getDict organic results, all right? And so this is gonna contain the organic results that we got before, and then we can save all that information into a single big string summarizing everything. This is a trick I've learned by reading a lot of the LangChain documentation. So I'm gonna say N, and I'm just gonna say N like this, and then like this, yeah, and dot join. And then what we're gonna join, we are going to join what? We're going to join all the results from the search, okay? And this search is going to contain what? It's going to contain the title of the URL, the snippet containing summarized information from that specific resource, and the original link, okay? So what does that look like? It looks like something like this. Join X title, and I'm not doing this like live, folks. I'm copying from my example, but I find it's more educational if I just write it down so that we can see everything little by little. But yeah, I definitely would have had some issue remembering all this stuff from scratch. There we go. So we have the title, the snippet, and the link. And then once we have all of that, we just say for X in results. We close up that list. And this list was opened where? It was opened right here. Excel title, and this should not be here. It should be right there. So that's pretty good. And we should be good to go now. X title, boom, 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 dot join. Yeah, and yep. I think this is, should be, everything should be correct here. Yeah. I see. Okay, I see. So this, like this, there we go. And now we return the contexts, okay? So the context from the search. Yeah, I'm just gonna say search results, okay? Search results, that's a better way to say it. And now, folks, so for you to get a sense of what this web search function does, let's test it out. So we're gonna write here, print web search. What's the best way to learn how to use LLMs for personal productivity, something like that, right? So we're gonna write that, we're gonna come over here, we're gonna run this, and we got a result issue with organic results. Organic results is not getDict. getDict SerpAPI, SerpAPI Google search, search.getDict. That should be correct. Why are we getting an annoyance here? Query, number of files, organic results. Let me just see if I did something wrong. Oh, that should be correct. Okay, that's annoying. Key error, organic results. Key error, organic results. Search, let me just see if I did something wrong here. Search, getDict. So let me just print search getDict first and see what happens. Error, invalid API key. Ah, okay. So I invalid API key, that's fair. Yeah, that's true, because that's not the correct name of my API key. Yeah, this is the correct name, folks. So I just mistook the name that I had on my API key. So this is the correct name. So now this should run correctly. Let's see. So I can run Python distributed something. And oh, that's weird. There you go, Python distributed. There you go. And now it should run, and it's still giving me issues with the API key. Invalid API key. That doesn't make a lot of sense. SerpAPI key. Oh, it just has the wrong name there, but now I think it's correct. There you go, folks. So this is very cool. So this is the result of the search. As you can see, it contains the title, it contains a piece of text from the resource, and it contains the original URL. And we have a bunch of those results here, all beautifully organized, which is very, very nice, right? Okay, so pretty cool. So now that we have that, we are very happy. And we can delete this one. And writing a reader file, it's a little bit easier, right? I'm going to let Cursor write that for me. And reading a file, same thing, right? And there's one thing we're not gonna assume that the model is going to update any files. We're just gonna assume the model is gonna write a new file every time, all right? And we're not gonna use scrape website as well. We're gonna simplify it for now for this demonstration. So we have the ability to write a file, we have the ability to read a file, but there's one thing missing here, which is the file path is going to be the joining with the folder base so that we always save it in the place that we want, okay? So that's what we're gonna write every time here. There you go. And now that we have that, that's beautiful. We can move on to the next part. Write a file, read a file. And now that we have those parts, we can write a little dictionary that essentially maps the string names of the functions to their actual functions, And we're going to use this tool mapping to create our agents with the right tools when we run the agent every time. So web search, write a file, read a file. There you go. So this is what we have, okay? And now that we have that, we can finally write the function that creates the agent, okay? So that we're going to write create an agent. And this is going to take a LLM model like ChatGPT or Claude or whatever, and some tools, okay? And what this thing is going to do is create an agent from given the task and the tools given, all right? And so it's going to create an agent with a set of tools, okay? So it's going to say, we're going to have tools list here. This is going to be the list of the tools for the agent. And we're going to look, we're going to say for tool in tools, okay? Because these are the tools that were identified in that specific task. And then here we're going to say tool is equal to tool.strip that I added. And this is a step that, you know, obviously I could have done this maybe when I parsed the tools before. And I don't know what I'm doing here. And this is probably like a useless step that I'm going to remove at some point. But for now, this is what we have. And now we're gonna create the tool in the structure that we need for LlamaIndex. So that requires us to do function tool from defaults, okay? And now here we're gonna say fn is equal to tool mapping tool, okay? Because the tool is gonna be the string after stripping this, like web search, read file, etc. And that's what we're gonna do. This gives us an actual tool that we can add to our list. So we can say tools list dot append tool. And now we're good to go, folks. So now we have all the tools that we need, and we have the LLM that we're going to use. So what does that mean? It means that we're going to return the React agent given the tools list. So we give it a tools. We give this list of tools. We set LLM to LLM, and we set verbose to true, just so when we demonstrate it, it works great. And max iterations we're going to set to 10. Which is a good number for any agent to perform a simple web search and write a report task. Okay, so this is awesome. We have an agent, and now we can finally put everything together and see if this automation works. So I'm going to write main, and then in the main function, this is where we're going to run everything. Okay, so the first thing that we're going to do is we're going to treat this as a CLI tool. So the task string is going to be sys.argv1, argv1. So that means that we're expecting the user to run the Python script and then give one string with all the tasks, okay? At least for the beginning, this is what we're doing. And now we're gonna set up our LLM. So Llama OpenAI, we set the model to GPT-4o mini. No, we actually set the model to the model agent, right? So model agent. And then we set the system prompt. And the system prompt is kind of, I did a big system prompt for this because this is where we control how the agent performs the tasks. So I'm just gonna copy the system prompt that I wrote. It's not like a super optimized system prompt, but it should be good enough. So what is going on over here? We're saying you're a helpful assistant that can search the web. And we're saying you're a helpful assistant that can search the web. Read and write to files. I'm going to remove this stuff because we're not going to be doing this right now, at least not right now. If you're given the right file tool, you should always use it at the end of the task to compile the outputs of the research or other tasks. When given the web search tool, you should always use it to search the web for information relevant to the task. 1 to 3 times at the max, then write the results. Okay, so essentially I'm trying to control a little bit how the model is going to perform the tasks so that we control for issues like, you know, a never-ending loop or not writing to file, etc. Okay, and I always want an organized document with the sources that were used, etc., etc. Basic input for an agent that does research. Okay, so now we have to generate our task list. So we go generate task list from that task string. Okay, so task string, task strn. There you go. We updated that. So that creates our task list. And then what we do is we say we're gonna capture everything that happens in that loop. So we're gonna say responses equal to a list, and then we're gonna say for task and task list, agent task, and then agent tools is equal to extract agent tasks and tools. And then agent is equal to create an agent with the LLM and the tools. The response is, this is what we're calling the agent to perform the task. And then we append that response, and then we return that response. I don't know why we return that response, but yeah, sure. We return the response at least. No, that doesn't make sense. We're just gonna response agent.chat, and then maybe we print the response. So maybe we just print the response. I feel like that's good enough. Yeah, so we can write something like processing task X, and then we can say output, something like print output, and then the output is like this, and then this, and this can go over there. And we're not gonna do a list anymore. I don't know why I was doing that before. All right, folks, so this is pretty good. So now we have this, we can test. So now let's test this out. So we say Python distributed agent tasker, and we're gonna give it a test. So research about best foods to eat to improve cardio. And then I'm gonna say web search, and then the ability to write a file. And I also want write a mini report on how to study effectively using AI tools. So I want the model to search the web and write a file again. All right. So we have 2 tasks. Let's see if the model properly identifies the tasks and does everything that we need. Running that now, folks. Processing the right task. So as you can see, the model is now doing the research on the stuff that we asked. Okay, so it generated a very cool list of like a bunch of foods, and then everything looks nice. And I don't know if it wrote to a file. I don't know if it wrote to a file, folks. So let's see if it wrote to a file somewhere. And if it didn't, that's we're gonna have to do something about that. Okay, beautiful. It finished the task. It did the research on all the stuff that we asked. and we can test. That's one mistake that I made, folks. I did not create the folder agent artifacts. So that was bad. So let's just create agent artifacts. There you go. And now let's test again. And let's test again with a simple task. I'm going to test again with a simple task like research about LLMs for research and productivity, and write a report as a markdown file. And then I'm going to say web search, and then I'm going to say write file. I'm going to run that, and let's see what happens. Research, perfect. So the model is again doing the correct research. Great, looking good, looking good. Okay, and then row draw file. And now, folks, if I go list agent artifacts, you can see that the file was created. And if I open that file, we have that little mini report on that topic based on the research that it did with the correct URLs for the request. So that's awesome. So folks, now that we have this thing and it kind of works well, what we're going to do is we're going to set up a Telegram bot so that we can send these types of requests from our phone or from Telegram. All right. So I'm going to create a new file here. It's going to be called simple Telegram agent. Maybe I'll say tasker in the end here. Nice. And now, folks, we're going to import the functionalities that we wrote here into this Telegram bot agent. Okay. And so I'm going to copy the configuration, the setup for the Telegram bot so that I don't have to write boilerplate again. There you go. So here, folks, what we have is we have the Telegram stuff. This is using the latest Telegram package, and this is for building and interacting with the Telegram API. Okay. This is actually, we're not going to use LangChain. This is a node version of this example that I updated. And there you go. From the script that we created, which I have to update now, distributed agent tasker, we are importing the generate task list, extract agent tasks and tools, and create agent. Let me just make sure that, yeah. So let's give the name, there you go. Oh, extract agent tasks and tools. Let me put the right name here. There you go. Oh, there you go. Okay, so now I think that we're good. Extract agent tasks and tools. Beautiful stuff. Okay, so we have that. We have create agent. We have LlamaIndex input OpenAI. Okay, this is all looking good. Let's just test out, make sure that the boilerplate doesn't have any kind of weird issues. So I'm going to just run this simple Telegram agent tasker. It should run perfectly. Beautiful. All right, folks. So now what we're going to do is I need to set up, just like we did before, the LLM stuff. So again, boilerplate code. So I'm just going to copy that from my original file. And now we're going to start writing the good stuff. And this is the Telegram stuff, which I've learned how to do recently. So definitely not an expert on Telegram API, but I've learned that you got to start the bot. So you write a little start function. And then for update, it's going to take in this update object. And then context is going to take this context types dot default type. And then none. All right, beautiful stuff. And now here, this is the function that sends a message when the command start is issued. So this is kind of like how you start the bot from the Telegram side. Okay, so then the user is going to be update.effective user, and then await context.bot.send message. And what is the message, you may ask? Well, we got to first set the chat ID to the user.id. Actually, you set the chat ID not to the user, because there's no user here. It's to update.effective chat ID. There you go. And then you set the text to, hi, I am the agent tasker, whatever, whatever. Okay. And we set parse mode to markdown v2. Okay, that's interesting. user.mention markdown v2. I'm a bot. Okay, so I'm gonna copy the one that I think I took this from their documentation, maybe with a few differences. I don't know why I'm doing mention markdown. I don't think I need this. I feel like this part I probably took from some code or whatever. So let's just say hi. I'm an AI agent. Ask me to do anything. So hi, I'm an AI agent. I'm an AI agent. Ask me to do anything. Okay, and there you go, folks. I think that this is pretty good. So now we have our async start function, and now we need a function to handle the message. So for that, folks, the handle message function is going to be essentially the function that reproduces our script from before, right? The script that executes the AI logic and gives that to the user. Okay. So for that, I'm gonna recopy, because this is just gonna be redoing the main function, folks, from what we just did. So I'm just gonna copy that, and then we're gonna walk through what that code looks like. There you go. So folks, what is going on over here? Let me just delete this. So folks, here, this is what we have. So the inputs are going to be the update. It's going to be, reading for the messages from the user, the context, and what's going to happen is it's going to take in the message, and then it's going to generate that task list, just like we were doing in the main function of the previous script. It's going to loop over it, print so that I can inspect and debug in the terminal, and then it's going to extract the agent tasks and tools, create an agent, execute the agent, and then append the response to a list. And we do that so that we can then return that as a response to the user. So we're going to say, await context bot send message. We're going to send the message to the user. And we're going to say, look, for this task, this is the response. So we call response dot response. And we do response.response because it's the response. It's going to be an object that has this response attribute, because that's how when you run an agent with LlamaIndex, that's how it works. Okay, beautiful stuff. So now, folks, that we have that and everything is working gorgeously and marvelously, we do a little exception where if there's a mistake, we just say, sorry, we could not process your request, and then log the error. Now that we have that, everything is going wonderfully well. What we can do is add some error handling, which is pretty boilerplate for the Telegram API. So that's essentially just saying, look, update caused error, and we show the error. And once we've done that, we can finally write our main function for this bot. So for this one, we're going to say, start the bot. And then we're gonna say we're gonna need to get the token for the Telegram bot. Now, if you don't know how to get this token, it's pretty easy. All you need to do is you need to go to your Telegram app. You go to bot fodder, which is a bot that you can interact with and create and edit different bots in Telegram. And then there you can say new bot and then create your bot, which will give you a token so that you can use it to send HTTP API requests to that bot. And I'm going to leave a link in the description, kind of indicating a tutorial where you can easily set that up. It's just a few steps. It's just literally you can take your phone and just figure everything else pretty easily. Now, on the API side, on the Telegram side, we're going to set up our application. And for that, we don't need application. We need an application builder. So cursor was doing a mistake there. So yeah, it's .token.build, not the way they was doing before. There you go. Application builder, application builder like this, .token.build, perfect. And then command handler start. I did not add a help message because this is just a demo. And filter text, handle message, everything working beautifully. I think that everything here is correct. I added the error handling, and now I can run the app. So now, folks, finally, we are ready to play around with this and check it out. So What am I going to do? I'm going to run this. I'm going to run simple Telegram agent tasker. And hopefully, oh, that did not work because I have to. You must pass the token you received from Ballfather. There you go. So what I'm going to do now is I'm going to pass the Telegram token by exporting my token to this example. So I'm going to just say export Telegram bot token. And I'm going to delete this token after this video, folks. So don't go around copying this token. And now that I did that, I can run that and this should run just fine. There you go, folks. And now this application is starting, I can go to Telegram. So I'm going to open up Telegram. There you go. And I'm going to clear this chat history here. And now I'm going to execute a task. So first I start. So as you can see, it sends me the correct message. So now I'm going to say, look, first thing is research about optimal studying practices for researchers, for optimal studying practices for people using AI. I don't know. I just some random task. And I'm going to say web search and write file. But I also want the model to write a mini report named why pancakes are better than waffles.md, arguing for pancakes versus waffles. And then I'm going to say web search, and then I'm going to say write file. All right, so we have two tasks. Let's see if the agent can perform them and do something useful. So I'm going to send that out. So as you can see in the background here, the agent is executing everything. It's researching stuff. It's going through resources, etc. It sends me the report about studying. That's very nice. And now it's running the task about the pancake. And it did wrote the report. That's awesome. And now it's finished. And it's actually super fast. So that's pretty cool. And let's see if it generated what I asked. It did. Look at that. Why pancakes are better than waffles. It has all the research. It has all the information. And also it generated this LLM for research and productivity. That's pretty nice. So folks, as you can see, our agent is working beautifully. And yeah, I guess that's it, folks. If you like this video, don't forget to like and subscribe. And see you next time. Cheers.